Hi and welcome to a brand new video. So in this video, we're going to be tackling the problem on the screen. We're given a string s and an integer k. And what we can do is we can take any of the first k letters of the string s and append it to the end. And the ultimate goal is to return the lexicographically smallest string after you apply this as many times as you want. So for example, as you can see here, if we just move C to the end, move B to the end, that's what we get. Here, we move B to the end, but then we can, move any of the remaining three, right? Because K is 3. So once we move this to the end here, then we can move C because it's one of the first three. So I'll just remake the string right over here. So that is what we're going to be trying to solve. So first, before we get into it, let's explain how this method will work. So let's say we have the string ACB where k is equal to 1. Now there's not really much we can do except for, actually let me not make it ACB, let's make it CAB. So there's nothing more we can do except for keep moving these till the end until we have the smallest possible value. So if k equals 1, we can't really, all we do is just rotate the string until it's the smallest. Because there's not much, because you can't do anything else than that. And something else to consider is that how many times do we need to rotate the string? Well, you only need to rotate through this because then it'll come back to the thing. So what we're going to do is we're going to iterate through once, not first, once, and then we're going to find smallest. And that is the strategy with k plus 1 because you cannot swap the positions of two letters unless you're moving it to the end. However, what if you have something like BAACA and k is greater than 3? Now first, before we get into this, let's talk about what happens when k is 2. And we have, let's say, A, C, D right here. So now that k is 2, we can move either of these two to the end. So we can make it ADC, or we can make it CDA. And then we can move either of these two. So this would make it ACD. So essentially what we're doing when we compare these two together, is that we can swap the indexes of any two letters. So here we just switched these two. But for example, in a longer string, B, A, C, D, what we can do is we can move either of these to the end, so we move B. Then we move either of these two, we move C. Then we move D. And what we did here is we swapped these first two. And if let's actually remove that example. If we do A, B, D, C, so let's see some other letters being switched, or even better, let's do B, D, A, C. What we do is we first move D to the end, A, B, A, C, D. We move B to the end, A, B, nope, not A, B. A, C, D, B, move C to the end, and move D to the end. So as you can see, we're basically we have the ability to swap the positions of any two. So we first swapped these two, we swapped these two, we swapped these two. So as you can see, now with any version of this iteration, we can switch any two if k is equal to 2, or you can do the same thing if k is greater, just you will have more, you can do it more quickly. So if k is greater than 1, you can switch the positions of any two indexes. So this ability makes it super helpful to us because now we have the ability to switch any two indexes, and therefore if we have an unsorted string, there is going to be some, if k is greater than 1, there's going to be some way to just make it completely sorted. So if k is greater than 1, all we need to do is sort the string. So let's kind of review what we've done so far. So we've said that if k is equal to 1, then we need to rotate until and we find the smallest rotation. So basically smallest rotation. But if k is greater than 1, all we need to do is sort the string, because there's going to be some way to swap the letters to get that sorted string. So now that we've talked about the strategy, let's see whether we can code it. Here I am at my coding editor, and let's first do if k equals 1. So we need to make these two conditions, like I just said, inside the notepad. I explained that if k equals 1, there's a different strategy than if it's greater than 1. So if it's greater than 1, remember what we decided is that we need to sort the array. So just create an array out of s.char to char array. We arrays.sort array. And then we just return string.value of array. And this just converts it to a char array for us. Or it takes the char array and turns it into a string. But if k equals 1, we need to rotate it until we find the smallest rotation. So what I'm going to do is I'm going to create just a duplicate of s, and then I'm going to iterate through s. And I'm going to first, we need to find the rotation string. And so I'm just going to set the rotated string to temp. And what is that? Well, what we do is we take the current index and we do s.substring of I, and we add it to s.substring of 0, comma I. And what we're doing is we're basically switching the end of the string from the index to the front. We're moving it to the front. And this is basically what it means to have a rotated string. And then we just compare it to our array, this R string here, and if it's less than 0, then we're going to set array to temp. So temp here is, so this R string is basically the smallest rotation string. So I can actually just rename it there to make it easier. And then after rotating it and finding the smallest, all you need to do is return that string. So if you run this code here, as you can see, we got the answers in the notepad. The first one just rotates it until it gets the smallest, and the second one sorts it. So hope this video was helpful, and see you in the next video.